Let's take one more problem of the similar type. The type was that we did in the lecture number 14, a cos x plus b sin x plus c dx. I had already explained this type and the method that we are going to follow for solving problems on this type. So I have taken a question. Let's solve few more questions on this type. So it is, I take third problem here. So 1 upon 2 plus cos x minus sin x. So what are the things which I told you to recognize the type? This type you can recognize by following the numerator. The numerator has to be 1 dx. So see, you have 1 dx in numerator. What more should be followed? The denominator should have terms of cos x, sin x and a constant, okay, or it should be terms of cos x and a constant, or simply sin x and a constant. Okay, like suppose in a problem you notice, in a particular problem, suppose you notice that you don't have sin x term. So the question here is, if I do not have sin x term, is this problem also the same type? If there are no sin x terms in the denominator, so is this problem also the same type? The answer is yes. Why? Because now here we can say that the number b, which is a real constant, it assumes value 0. So when the value of b is 0, 0 times sin x is 0. So you will not get sin x. So remember, you may have the term of cos x, sin x and a constant, or you may have only term of cos x and a constant, or you may have a term of sin x and a constant and no cos x. Okay, so all these different types of problem you will different problems you will categorize in the same type. So 1 upon 2 plus cos x minus sin x, and see how do I solve. I know the method. The method is put tan x by 2 as t. We always begin with tan x by 2 as t. Many students are always confused that why put tan x by 2 as t if there is no tan x by 2 seen in the integrand. Most students, they are always troubled by the substitution, because what they see is they see no tan x by 2 in the integrand. If there is no tan x by 2 in the integrand, then why substitute tan x by 2 as t? Okay, see students, we got here cos x, and we know cos x can be written as 1 minus tan square x by 2 upon 1 plus tan square x by 2. So here cos x and sin x, we are looking at them in their half angle formula, okay, using tan. That's why we are putting tan x by 2 as t. So the next step, now what I write is, I write, therefore x by 2 is tan inverse of t, and x equals to 2 times tan inverse of t. X equals to 2 times tan inverse of t. So now I differentiate this with respect to t. Differentiating with respect to t, we will get d by dt of x equals to d by dt of tan inverse t, 2 tan inverse t. So this I get here dx by dt equals to 2 is a constant, and d by dt of tan inverse t, which is 1 upon 1 plus t square. So now I multiply dt here in the numerator on the right side. I get dx equals to 2 dt dx equals to 2 dt upon 1 plus t square. Now what I do is, I write the new integral. Okay, so the old integral was, what was the old integral? The old integral is the original integral that we have to integrate. And where is that? Here it is. Here it is. I want to write new integral. What does that mean? The new integral which I will write, it will be completely in terms of t. Remember that first. The new integral will be completely in terms of t. So in the new integral, you will have dx. 1 dx, you will write it as 2 dt upon 1 plus t square. Remember, for dx, what you will write? You will write this. So remember, students, when you write 2 dt upon 1 plus t square, you are taking the differential as dt now. Remember, once you get dt, then inside the integral, you cannot have anything in x. That means even cos x has to be written in terms of t, and sin x also has to be written in terms of t. Okay, keeping this in mind, now I understand that I need to write one more step. Before I come to the new integral, I need to write one more step. So see here, what I write. We know that cos x formula, cos x half angle formula in terms of tan is 1 minus tan square x by 2 upon 1 plus tan square x by 2. So cos x will become 1 minus t square, because you have written tan x by 2 as t. So 1 minus t square upon 1 plus t square. Similarly, and you know about sin x also. So here for cos x, what you will write, students? You will write for cos x in the old integral. When you will write the new integral in terms of t, you will substitute cos x as 1 minus t square upon 1 plus t square. Okay. And sin x, what is sin x formula? Sin x is 2 tan x by 2 upon 1 plus tan square x by 2. I will substitute. So I will substitute tan x by 2 as t. So we will get 2t upon 1 plus t square. This is we will get. Okay. So see, students, what we got. We are going to write for cos x, we are going to write this. For sin x, we are going to write this. And for dx, we are going to write this. Okay. Now these three things, when you do, you will get the new integral in t. Okay, so let's begin. I equals to integral 1 dx. So what will I get? So the new integral will be I equals to integral in place of 1 dx. See, students, 1 dx. What is 1 dx? 1 dx is dx. 2 dt over 1 plus t square. 2 dt over 1 plus t square. Then you have 2 plus 2 written as it is plus cos x. For cos x, what you are going to write? You are writing this. You have 1 minus t square over 1 plus t square. Then you have minus sin x. For sin x, you are going to write this. Minus 2t over 1 plus t square. So you have therefore I equals to 2 dt upon 1 plus t square. And here the LCM is 1 plus t square. LCM is 1 plus t square. You get here 2 into 1 plus t square plus 1 minus t square minus 2t. Okay. See, I'm simplifying the whole denominator. I notice that here the LCM is 1 plus t square here. What is LCM here? 1 plus t square. The LCM is 1 plus t square because the denominator of 2 is 1 and these two have 1 plus t square in the denominator. So the LCM is 1 plus t square, and then here first term I got 2 into 1 plus t square, and since these two already have 1 plus t square in their denominator, the numerator is written as it is. Now what happens is you are going to get these two cancelled, these two cancels, and then you have I equals to 2 dt. Multiply this 2 inside, you get 2 plus 2t square plus 1 minus t square minus 2t. So here I get, therefore I equals to 2 dt upon, here 2 plus 1 is 3, then you have 2t square minus t square is t square minus 2t. So you have this 2 you can take out, this 2 can be written out. So 2 outside, 1 upon, you have t square minus 2t plus 3 and dt. So now you can check, students, what have we achieved? We have written the given integral which was at one point in time, the given integral which was this. Now what you have turned this into? You have turned this into 1 upon quadratic. See, 1 upon quadratic. And this is in t, not in x. So I hope you have followed. How do we solve this? After this, you know the method. We have to find the last term. We have to find the last term because t square coefficient is already 1. So how do I find the last term? The last term is half the coefficient of t. Half the coefficient of t. What is half of minus 2? Half of minus 2 is minus 1. And then what? Then square. So I get equal to 1. What is the last term? Last term is plus 1. So what will I do, students? I will add plus 1 and subtract plus 1. Okay. So I get I equals to 2 times 1 upon t square minus 2t plus 1 minus 1 plus 3 dt. So next step is 2 upon, now see the first three terms get me a perfect square, t minus 1 the whole square plus 2, I can write plus root 2 square and dt. What is it equal to? It is equal to tan inverse of, you can check now, this is where you can use the result. Yes, see, you can use the result here. Why? Because this is 1 upon variable square plus constant square. Set 1 theories. 1 upon x square plus a square is 1 upon a tan inverse of x by a. So here I will have I equals to 2 times 1 upon a tan inverse of x by a, 1 upon root 2 tan inverse of t minus 1 upon root 2 plus c. 1 upon root 2 tan inverse of t minus 1 upon root 2 plus c. And this gives you here root 2. 2 upon root 2 is root 2 tan inverse of, and what was that t? T was tan x by 2 minus 1 upon root 2 plus c. This is final answer which we got. This is final answer. You can see the whole video once again to understand. This is very important type of problem. So in your textbook or whatever notes you are referring, if you see some more problems of this type, you must practice because these problems are favorite problems for exams. Thank you. Let's have one more question on similar type. Let's have one more question on same type, rather. Same type. See this question. In this, you notice that integrand, the numerator is 1 as it is required for the type. Numerator is 1 and denominator is in the form a plus or c plus a sine, oh, this time it is 2x. Yes, it is constant multiplied with sine 2x. The angle is double. So it is c plus b sine 2x plus this is a and a into cos 2x. So if I want to describe this type comparing the previous type, how should I do it? If I want to describe this type comparing the previous type, how should I do it? So see students, the question that you solved earlier and in this, you have a term, you have 1 in the numerator as it is required for the type. In the denominator, you have a constant term. You have a constant term here. Then you have a term of sine, but the angle is not x, angle is 2x. You have a term of cos. Once again, the angle is not x, the angle is 2x. Now, what did you do when you had sine x and cos x? Do you remember? Suppose this question had been 1 over 3 plus 2 sine x plus 4 cos x dx. If the question had been this, what would you have done? If the question had been this, what would you have done? You would have taken sine x and cos x with their half angle formula in terms of tan. What would you have done? You would have taken sine x as 2 tan x by 2, 1 upon 1 plus tan square x by 2, and cos x you would have considered as 1 minus tan square x by 2 upon 1 plus tan square x by 2. And since you take sin x as this and cos x as this, these two make you substitute tan x by 2 as t. Since you see sin x as this and you see cos x as this, that is the reason you put tan x by 2 as t. So this thing becomes 2t upon 1 plus t square in the new integral, and this thing becomes 1 minus t square upon 1 plus t square in the new integral. But what do we have here? What do we have here? See, we have sine of 2x and cos of 2x. So how is it going to matter? It will give us the half angle formula, and the half angle formula will be in terms of tan of x, not tan x by 2. When you have sine x, you write half angle formula, you get here x by 2 because half of x is x by 2. When you have cos x, you get x by 2. But if I have sine of 2x, what would the formula be? It would be tan 2 tan x upon 1 plus tan square x. And cos 2x, since I have 2x on the left, I'm writing half angle formula for cos 2x. It is 1 minus tan square x upon 1 plus tan square x. This is how it is going to be. And I will substitute. So since I'm getting sine 2x and cos 2x, in terms of tan of x, what would the substitution be? Earlier the substitution was tan x by 2 as t. What had you done? You had put, if you remember, in the earlier problem, when you had cos of x and sine of x, angle was x, you had put tan x by 2 as t. Here you will put tan of x as t. You will put tan of x as t. I think I have explained you much, and this explanation should be helpful for you, and now we can go ahead. So here, students, I write what? So the solution starts as follows. This is question number 7. I write here, let I equals to, my assumption is to be integral I. So I write next step, put tan x as t. Put tan of x equals to t. So x equals to tan inverse of t. Now I differentiate with respect to t. I get d by dt of x, and here I get d by dt of tan inverse t. So this will get me, this gets me dx by dt equals to 1 over 1 plus t square. What do I do here now, students? I substitute. So I multiply this dt on the right side, so I get dx equals to 1 upon 1 plus t square into dt, that is dt upon 1 plus t square. Okay, so for 1 dx, what are you going to write for 1 dx? 1 dx you will write dt upon 1 plus t square. Now you have to write for sine 2x and cos 2x, which formula you already know. You will write, we know that sine of 2x equals to 2 tan x upon 1 plus tan square x. That is 2t upon 1 plus t square. And cos of 2x is 1 minus tan square x by 2 upon 1 plus tan square x by 2, which is 1 minus t square upon 1 plus t square. Therefore, the new integral will be I equals to, you know, what is 1 dx? 1 dx is dt upon 1 plus t square, then upon 3 plus 2 times sine 2x. What is sine 2x? Sine 2x is here, you can check. It is 2t upon 1 plus t square plus 4 cos 2x. 4 cos 2x is 1 minus t square upon 1 plus t square. The bracket is closed. You now have therefore I equals to dt upon 1 plus t square, and we shall simplify the denominator. Here I understand that it is 1 plus t square, which is the LCM of the denominator. So here I have 1 plus t square. I write here 1 plus t square. Okay, the constant is 3 without 1 plus t square in the denominator. It has got 1 in the denominator. So the first term that you will get is 3 times 1 plus t square, plus in the second you notice 1 plus t square is there in the denominator. So you get 2 multiplied to this, only 4t. You get 4t plus 4t plus 4 times 1 minus t square. That is 4 times 1 minus t square. And now what happens next is this 1 plus t square cancels. You have now I equals to dt divided by, see, multiply this 3 inside, so you have 3 plus 3t square plus 4t plus 4 minus 4t square. So what do you have? You have 1 dt, dt is 1 dt. 3t square minus 4t square is minus t square. So you have 3 plus 4, 7 plus 4t. 4 plus 3 is 7 plus 4t minus t square, and this is 1 upon quadratic. I have solved many problems for 1 upon quadratic, and this is another. You will solve this. You know the method. The method is you will first make the coefficient of t square positive 1, for which you have to take minus 1 common. That minus 1 you can take it outside. So it will become 1 upon t square minus 4t minus 7. Then you will find out the proper last term. Then you will get 2 squares, and then that is constant square, variable square, and accordingly you will use the result. Okay, you must try this problem on your own. Complete it. After you will have completed the answer which you will get in t, and do not forget to resubstitute what t was. T was tan of x. What was t? T was tan of x. So I want you all to complete this. Pause the video and complete it. Let me see how you get it. Thank you. When you will complete this, you should get this as the final answer. When you complete the integration for 1 upon quadratic, which you are getting here, the final answer for the question is given here. This will be the final answer. Now we begin with a new type of problem and see what is that problem. The new type of problem which we will learn is, I write the type. The type is what is the type? The type is no, this is not the type. I know what you are thinking. You are thinking that we have already done this problem. This is 1 upon quadratic which I wrote. So now the type, this type 1 upon quadratic ax square plus bx plus c has already done. We are going to see the new type, and which is numerator px plus q upon ax square plus bx plus c. Which type we are going to do? Px plus q upon ax square plus bx plus c, where p, q, a, b, c all are real constants. Okay. There is one more name for this type, and the name is linear upon quadratic. This time the numerator is not 1. What is numerator, students? It's a linear algebraic function. So linear upon quadratic. Linear upon quadratic is the name. So here we write linear upon quadratic. Linear upon quadratic dx is the name of the type. Okay, now I shall give you the method. What is the method? The method follows as this. Step 1. In method, you have step 1 as, see, what you will do is, you will differentiate the quadratic expression. And as you know, students, whenever a quadratic is differentiated, we end up with a linear expression. Like, see, for example, if I'm writing d by dx of 5x square minus 7x plus 12. So what will be derivative of 5x square? It is 5 into 2x, that is 10x. 5 into 2x, that is 10x minus 7. Okay. So what we understand that whenever a quadratic is differentiated, we get a linear, right? Linear expression. So the first step is adjust the derivative of quadratic in place of linear. expression. So what does it mean? It means you will differentiate the quadratic, and after differentiating quadratic, whatever you get, you should try to adjust that here. Okay, that is, you should try to write this linear, that is px plus q, you should try to write using the derivative which you got from ax square plus bx plus c. So it will be more clear when we will solve one problem. So adjust the derivative of quadratic in place of linear. Step 2. Step 2 is split the denominator. Split the denominator for the derivative of quadratic. Split the denominator for the derivative of quadratic. What does that mean? Once you have expressed the numerator using the derivative of denominator, that is, once you have expressed the linear using the derivative of quadratic, you should try to split the denominator for the derivative of quadratic. Okay, split the denominator. What is denominator? Denominator is nothing but quadratic only. So you could also write, in place of denominator, you can write here split the quadratic, that is separately divide. Okay, after this, step 3 will be step 3. Step 3 is use integral f dash x upon f of x dx and integral 1 upon quadratic dx to complete the solution. So now one by one I shall explain all this step. What you should first do is you should try to first copy, write everything that I have written. So linear upon quadratic, I will take a problem. So here for linear upon quadratic, I write here 1, 1, and it is, let I equals to 3x plus 4 divided by x square plus 6x plus 5. So what is our aim? Our aim is to integrate this result, this particular integrand. So as you all know, integrating a given function is all about applying a result. So do you have any result which you can directly apply here? The answer is no. We do not have any result, ready-made result which we can apply here. Okay, by ready-made result, what I'm saying is, suppose I have here, suppose I have 2x upon x square, 2x plus 6 upon x square plus 6x plus 5. Okay, suppose I have something like this. So here what I notice that denominator if denominator differentiated, it will give us 2x plus 6, which I have in the numerator. So here I have a ready-made result working. What is it? It is f dash x upon f of x dx, and it is equal to log of mod of f of x plus c. So by ready-made results, I have this meaning. So here the answer will be for this. What will be the answer? The answer will be log of mod of denominator x square plus 6x plus 5 plus c, and the integration is over. So what I'm asking you all is, do I have a ready-made result working for this linear upon quadratic? We have got so many results. If you see from the lecture number 1 till this is lecture number 15, we have got so many results. But is any result working here directly which will help me write the integration in one step? The answer is no. So what should I do? Transformation. I should try transforming this integral, this integrand, I should try to transform in such a way I can use a result there on the transformed integrand. Okay, I have to write this in a different form. For that, see how do I go ahead. The first step is, what was the first step if you remember? For linear upon quadratic, see what I have is in the form px plus q upon ax square plus bx plus c. You can check. We have px plus q upon ax square plus bx plus c. A is 1. So students, the first step was adjust the derivative. The first step was adjust the derivative of quadratic. Adjust the derivative of quadratic in place of linear expression. Okay, so you will first differentiate the quadratic. Derivative of x square plus 6x plus 5 it is. What is derivative of x square plus 6x? Derivative of x square plus 6x is 2x plus 6. 2x plus 6. 2x plus 6. So from the first step, I need to adjust this. I need to adjust this in place of 3x plus 4. So see how do I do it? I will write here 3 common. So 3 is common. I get x plus 4 by 3. And denominator is unchanged, x square plus 6x plus 5 dx. Then this 3, I write it out. So 3 is out. And what I do is, this is x plus 4 by 3, x plus 4 by 3 upon x square plus 6x plus 5. Remember students, the numerator I want numerator to be 2x plus 6. So what I do, I multiply 2 here. I multiply 2 here. So if I'm multiplying 2 here, I have to divide by 2. I will have to divide by 2, right? So see what it will become. So now what happens is, I get here I equals to 3 over 2, and this 2 now you multiply inside. Why? Because your aim is to get 2x plus 6. So 2x plus 8 by 3 and divided by, denominator is unchanged, x square plus 6x plus 5 and dx. So I got 2x. I'm working for 2x plus 6. Now what I will do, I will add 6 and subtract 6. So I equals to 3 by 2. And here I have 2x plus 6 minus 6 plus 8 over 3 and dx. And here I have x square plus 6x plus 5. So the next step is I equals to 3 by 2 outside. You have 2x plus 6, and then the next two steps, the next two terms, if you remember, I always told you that don't commit mistake in this. So you know what I will do, minus 6 plus 8 by 3, how I manage? I will always write plus sign here. I will write plus sign here, and then I will write plus sign here, and then the LCM is 3. LCM is 3. So what I get, I had here negative 6. Negative 6 it is. So minus 18 plus 8. Minus 18 plus 8 dx. Minus 18 plus 8 dx. And here you have x square plus 6x plus 5. What do I do next? I noticed that this is the denominator's derivative. That is what our plan was. This was our plan. What? Adjust the derivative of quadratic in numerator. So I got the derivative of quadratic, and quadratic happens to be the denominator. Okay. So what I will do is, now you can check what was the next step. The next step was split the denominator. The next step was split the denominator. Split the denominator for the derivative of quadratic. So I shall now be splitting the denominator. If you remember, a plus b upon c can be written as a upon c plus b upon c. This is known as separately dividing by the denominator each term. So same thing I'm going to do here. I shall write 2x plus 6 upon denominator and this thing upon denominator. Okay. So here I have, therefore I equals to, I equals to 3 upon 2, and here I have 2x plus 6 upon x square plus 6x plus 5, and this is minus 10 upon 3. Remember, this is plus here, but inside you get minus 10 upon 3, and you divide, separately divide by x square plus 6x plus 5 and dx. What are you going to get next? You will get 3 by 2. And now I write separate integral. I write integral for this and integral. I write integral for this term and this term. Okay, so see what do I get? I get integral 2x plus 6 upon x square plus 6x plus 5 dx. Integral 2x plus 6 upon x square plus 6x plus 5 dx minus, see this plus and this minus will be negative, and I get 10 upon 3 outside because it's a constant. So I'm left with 1 upon x square plus 6x plus 5 and dx. Next step, I multiply this 3 by 2 inside. I multiply 3 by 2 inside. So I get, therefore I equals to 3 upon 2 integral of 2x plus 6 upon integral 2x plus 6 upon x square plus 6x plus 5 x square plus 6x plus 5 dx. And when you multiply 3 by 2 with this term, see 3 by 2 multiplied this integral, this term, and then now this. So here 3 will cancel, 10 upon 2 will get you 5. So negative 5 and 1 upon x square plus 6x plus 5 and dx. Okay. Now see, as you know students, that this one is going to get integrated in the very next step. This one will be integrated in the very next step. Why so? The reason being that here you have, what do you have here? You have here integration, you have here derivative of denominator present in numerator. You can check derivative of denominator x square plus 6x plus 5, derivative is 2x plus 6. This was all our plan. It was all our plan. We had planned it this way, you know. So integration of this is going to happen in the next step, but this won't be, this cannot be integrated in the next step. Okay, it will take time, this because this is 1 upon quadratics. Now you know you'll have to find the last term and all that. So see, how do I do it? I write I equals to 3 upon 2 log of mod of, as you know, integration of f dash x. This is f dash x upon f of x. So it will be log of mod of denominator x square plus 6x plus 5. Okay, and since I have integrated this, I'll have to add one constant, so c dash. Now, normally what happens is when you are integrating all the integrals in a particular step all at once, so you don't write the constant of integration for individual integrals. You add all the constants and you write a single constant of integration c. But then that happens when you are integrating all the integrals at once, at one time only, when you integrate all the integrals. Now here what is happening, this is getting integrated in the next step. but this one is not going to be integrated. So what you will write? You will write this as minus 5. Okay, you will write this as minus 5 I1. I1. You write this as minus 5 I1, where I1 is this. This is now equation number 1. Now it is time we work on I1. I write here consider. I write here consider I1. What is I1? I1 is 1 upon x square plus 1 upon x square plus 6x plus 5. 1 upon x square plus 6x plus 5 dx. You know the method here. How will you integrate this? Okay. So here I1 is 1 upon quadratic. What is the method? We will, since the coefficient of x square is already 1, we will get the half of coefficient of x, which is 3. And square of that is 9. So I will add 9 and subtract 9, which is the proper last term. So I1 equals to integral 1 over x square plus 6x plus 9 minus 9 plus 5 and dx. So what do I get now? So here I will get here I1 equals to 1 over, now you know this 3 will get me the perfect square. It is x plus 3 the whole square, and then minus 9 plus 5 is minus 4, which is minus 2 square. Minus 2 square and dx. This is minus 9. Minus 9 plus 5 is minus 4. Minus 4 can be written as minus 2 the whole square. So what I will do, I will write, now I will apply the result, 1 upon variable square minus constant square, which is 1 upon 2a log of x minus a upon x plus a. So I will have I1 equals to 1 upon 2 into 2, 1 upon 2a. What is a here? A is 2. Log of x minus a upon x plus a. So x plus 3 minus 2, x plus a, x plus 3 plus 2 and plus c1. What I write? I add c1 because this is I1. So the final step which I get here is, I get the final step as, I1 equals to, I1 is 1 over 4 log of x plus 3 minus 2 is x plus 1 upon x plus 5, x plus 1 upon x plus 5 plus c1, and this is equation number 2. Equation number 2. What I do now, I use I1 in equation number 1, and that will be my final answer. So I write using I1 in equation 1, we get. So what I get the final I answered, that is I equals to, I get 3 over 2, log of, I get 3 over 2 log of mod of x square plus 6x plus 5, x square plus 6x plus 5 plus c dash, ignore that c dash, minus 5 I1. So minus 5 and I1 is this whole thing, right? So here I write minus 5 by 4 because you multiply 1 by 4 and minus 5. So minus 5 by 4 log of x plus 1 upon x plus 5 plus c1, okay, which will be, when you multiply minus 5, this is minus 5 c1. So you have minus 5 c1 and plus c dash. What is that c dash? C dash of this one, you know, when you have integrated the first one. So what I do next is c dash and minus 5 c1 plus c dash. This will get me another constant, which is c, capital C. So normally what we do is we don't write this complete thing. Instead, we write plus c, which is understood. So this is my final answer. This is final answer. For more practice, I'll write few more problems for you. You can solve one more question, two more questions of this type. You can take 2x plus 1. You can integrate 2x plus 1 upon x square plus 4x minus 5 dx. And you can also solve 3x 2x plus 3 upon 2x square plus 3x minus 1 dx. You can try these two problems. They're of similar type. What is that? Linear upon quadratic. That is linear upon quadratic. So after linear upon quadratic type, which we just solved, as you saw, we first saw the type linear upon quadratic. Then we took problem on linear upon quadratic. The next type now we are taking is linear upon root quadratic. Linear upon root quadratic. So what will happen? This we will have inside the square root. So px plus q, and the denominator we will have inside the square root. Linear upon root quadratic. Px plus q upon ax square plus bx plus c, or linear upon root of quadratic. So this is next type we are going to do. That's the small change in the denominator. In the earlier type, you had only ax square plus bx plus c. Here you have that inside the square root. So this is linear upon root quadratic. Now method. Amazingly, surprisingly, and fortunately, whatever you say, the method is same. What was the method earlier? The same method you are going to adopt here. And it is adjust the derivative of quadratic in place of linear expression. See, adjust the derivative of quadratic. You will ignore the square root that you have in the denominator, and you will just adjust the derivative of quadratic in place of linear expression. And once you are done with it, what you will do, once you are done with the derivative of quadratic in the linear, in the place of linear expression, you will split the denominator. You will split the denominator for the derivative of quadratic. Now here, what I will do is I will cover this quadratic, because this time in the earlier type, you know what happened? The denominator was equivalent to quadratic. But here the denominator is not equivalent to quadratic. The denominator is root of quadratic. But it is still okay. You know, we have to do the same. What? Once we will have obtained the derivative, once we will have obtained the derivative of quadratic in numerator, that is the required adjustments would have been done. We will split the denominator for the derivative of the quadratic. Okay, we will split the denominator for derivative of quadratic. Now, once you have split, you will get the integral of the type f dash x upon root f of x. You will get the integral of the type f dash x upon root f of x, and you will get 1 upon root quadratic. These two kind of integrals you will get, which you will integrate, because you already know how to integrate them. Okay. So if you remember the earlier type, we had got f dash x upon root f of, we had got f dash x upon f of x, because the square root was not there. And here we had got 1 upon quadratic in the previous type. But this time we are going to get with the square root. So let's take a problem and you will understand it very well. Everything is almost going to be same. First, fourth, it is, let I equals to integral 3x plus 4 upon square root of 2x square plus 2x plus 1 and dx. So the first step is adjust the derivative of quadratic in place of linear. So what is derivative of, what is d by dx of 2x square plus 2x plus 1? Derivative of 2x square is 2 into 2x, 4x plus 2. 2 into derivative of x square is 2x, so 4x plus 2. So here I want to get 4x plus 2. Okay, derivative of 1 is 0, so finally it is 4x plus 2. I will try to get 4x plus 2 here. See, I write here I equals to, I take 3 out, 3 is common, so I get here x plus 4 by 3, and then here the denominator is absolutely unchanged, nothing you change in the denominator, 2x square plus 2x plus 1. But now since you want 4x plus 2, here you will divide by 4 and multiply 4. Remember that. So you will divide by 4 and multiply 4. So the next step, you have this 3 is gone out. I write this 3 out. 3 is out, and here I divide by 4, so I could multiply 4. So this will become 4 times x plus 4 by 3 and square root of 2x square plus 2x plus 1, 2x plus 1 and dx. So the next step, what you get is, in the next step you get here I equals to 3 over 4 and 4x plus 16 by 3, 4x plus 16 by 3 divided by 2x square plus 2x plus 1 dx. Okay, I want 4x plus 2. The derivative of quadratic was 4x plus 2. Remember, we are looking for the derivative of quadratic in the place of linear, which is in the numerator. So you can say, in short, you are trying to get the derivative of quadratic in numerator. So 4x you have got. Now you want plus 2. So you will write I equals to 3 over 4, and you will write 4x plus 2 minus 2 plus 16 over 3, and the denominator, as you know, it is unchanged. So 2x square plus 2x plus 1. Okay, you get I equals to 3 by 4, and this is 4x plus 2, 4x plus 2, and as I told you, always take plus sign. So, and LCM is 3 here. So the advantage of taking plus sign is nothing you have to worry inside. Whatever sign a term has, it will come with the same sign. So minus 6 plus 16, and minus 6 plus 16, and here square root as it is, square root as it is. Okay, so you have here I equals to 3 by 4 and 4x plus 2. Now you split the denominator. What was denominator? 2x square plus 2x plus 1. So 4x plus 2 upon 2x square plus 2x plus 1. And here you have plus 10 by 3. 10 by 3. 16 minus 6 is 10 by 3. And square root of this completes. And here you have dx. Okay, so 2x square plus 2x plus 1. So next step, now I will write separate integral. Next step, I will write separate integral. So it is 3 by 4. I equals to 3 by 4 and integral of 4x plus 2, 4x plus 2 times 4x plus 2 times square root of 2x square plus 2x plus 1, 2x square plus 2x plus 1, dx plus here you have 10 by 3, this will go out. So 10 upon 3 times 1 over 2x square plus 2x plus 1 dx. Now I will multiply this 3 by 4 inside. So when you multiply, you get 3 upon 4 and 4x plus 2 upon square root of 2x square plus 2x plus 1 dx. And here when you multiply this, you will get 3 cancels, 10 by 4 you'll get 5 over 2 and 1 upon square root of 2x square plus 2x plus 1 dx. Okay, now students, here normally what happens, one can get tempted to get 2 out, take 2 common and cancel with this. See, 4x plus 2, you will think of, you get tempted to take 2 out because you see 2 common, but then remember, you will not do it because it is all planned. If you take 2 out, it is no more derivative of quadratic. You are working for the derivative of quadratic in the denominator inside the square root. So let it be 4x plus 2 only, don't do anything. So next step, this is what it is in the form f dash x upon root f of x. Do you remember f dash x upon root f of x? We had done this. If you have f dash x upon root f of x dx, then the integration is, if the integral is of the type f dash x upon root f of x, it is 2 root f of x plus c. So what will be the integration here? The integration here will be I equals to 3 upon 4 into 2 root 2x square plus 2x plus 1 plus c dash, because you integrated, so you write c dash plus 5 by 2, and I write this as I1. This is my equation number 1. Why I wrote I1? Because this I'll have to integrate separately. This I will have to integrate separately. Now we are done with everything, but I1 is still left. So we will take I1. I1 is this integral. I will write okay, I will write I1 equals to, now I1. Now I1. What is I1? I1 is 1 upon square root of 2x square plus 2x plus 1 dx. What is the next step? This is 1 upon root quadratic. We have done enough problem on that. The step says make the coefficient of x square positive 1. So I take 2 common. So I get x square plus x plus 1 by 2 dx. Make the coefficient of x square plus 1. So it is 2x square. I take 2 common. I get x square plus x plus 1 by 2. Now find out the proper last term. What is proper last term? The proper last term is half the coefficient of x and square of that. So right now I see it is coefficient of x is 1. So what is half of 1? It is 1 by 2, and square of that is 1 by 4. So what I do? I add 1 by 4 and I subtract 1 by 4. So the next step I have is, I get I equals to 1 over root 2. First of all, that root 2 can be taken out. Okay, which root 2? I meant this root 2. This is inside 2 into this bracket. So I can write root 2 outside. And then I have x square plus x plus half. So this is x square plus x plus 1 by 4. And I'm adding 1 by 4. So I subtract 1 by 4 and plus 1 by 2 dx. So this 1 by root 2 is outside. It is 1 by root 2 is outside, and here I have 1 upon square root of the first 3 terms will get me the perfect square. So x plus 1 by 2 the whole square, and the next 2 terms, it is half minus 1 by 4 is plus 1 by 4. Okay. You can check this, half, this is 1 by 4 negative. So half minus 1 by 4 is plus 1 by 4, plus 1 by 1 by 4. So it is 1 upon root 2, 1 over, and here this is square root of x plus 1 by 2 the whole square plus 1 by 2 the whole square, and here I can apply the result. What result? The result where we have integral 1 upon square root of variable square plus constant square. So I1 is, this was actually I1, so I1 is, therefore I1 is 1 upon root 2, and this is here, which one I am going to apply, which result am I going to apply? I am going to apply the result 1 upon square root of variable square plus constant square. That is log of variable, which is x plus half, plus the square root as it is, the square root exactly as it is. Okay, so the square root, and which is x plus 1 by 2 square plus 1 by 2 square mod closed plus c1 plus c1. So this is I1 1 upon root 2, 1 upon root 2 log mod x plus 1 by root 2, and when I say the square root, you know that this is same as this, which is same as this, which is same as this. So I write x square plus x plus half here. So this is x square plus x plus half plus c1. Okay, this is number 2. What do I do next? I write using I1 in equation number 1. I1 in equation number 1, we get the final answer. So therefore, using I1 in 1, we get, what do you get, students? You get I equals to, it was, okay, this can be simplified, 3 by 2 times square root. So it was 3 by 2 times square root of 2x square plus 2x plus 1, and then plus c dash. Ignore that c dash. We will adjust that c dash with the c1, and we will write another integration constant, that is c. So for time being, just ignore that c dash. The next we are having is 5 upon 2 plus 5 upon 2 I1. Okay, and I1 is this. So here I have plus 5 upon 2 into 1 upon root 2. I1 is 1 upon root 2 log of x plus half, log of x plus half plus square root of x square plus x plus half plus c1. Remember, here you have plus c1, which is multiplied with 5 by 2, because see, it is I1 multiplied with 5 by 2. So definitely I1 has got C1. So C1 will also be multiplied by 5 by 2. So you will have plus 5 by 2 C1, and earlier you had C dash. You remember you had C dash. So now this whole constant will give you C. So you will have therefore final answer as I equals to 3 by 2 square root of, you copy this as it is here, 2x square plus 2x plus 1 plus 5 over 2 root 2, and then you have log of mod of x plus half plus square root of x square plus x plus half plus c, where c is 5 upon 2 c1 plus c dash. This is final answer. This is final answer. Thank you. You can see the whole solution once again.